Your heart is racing, your palms are sweating, you're staring at an email. Nothing is chasing you, no claws, no teeth, just a blinking cursor and a deadline. But your body doesn't know that. It's reacting like a predator just stepped out of the tree line. Your muscles are tensing, your breath is shallow. Somewhere behind your eyes, a very old alarm system just went off. And here's the strange part. That alarm system wasn't built for emails. It wasn't built for traffic, or notifications, or awkward silences in meetings. It was built for something else entirely. Something that hasn't chased a human being in tens of thousands of years. So why is it still going off? To understand that, you have to go back. Not a few decades, not a few centuries. You have to go back to a savanna 500,000 years ago, where a human ancestor is crouched in tall grass, perfectly still. There's a rustle nearby. It could be wind. It could be a leopard. In that half second, the ancestor's brain doesn't have time to think it through carefully. There's no moment to weigh evidence, to consider probabilities, to reason it out logically. There's only time to react. And the ancestors who reacted fastest, who treated every rustle as a possible threat, were the ones who survived long enough to have children. The ones who paused to think it over usually didn't get a second chance. This is the birth of a system neuroscientists now call the fight or flight response, a term first coined by physiologist Walter Cannon in the early 20th century. Cannon discovered that under threat, the body floods itself with adrenaline, redirecting blood away from digestion and toward the muscles, sharpening the senses, preparing to run or to fight in an instant. It's a beautiful system. It's also incredibly blunt, because at the center of it sits a small almond-shaped cluster of neurons called the amygdala. And the amygdala doesn't distinguish well between a leopard in the grass and a harsh email from your boss. Neuroscientist Joseph Ledoux spent decades mapping exactly how this works. He found that sensory information about a potential threat reaches the amygdala through two separate pathways. One is slow and accurate, running through the cortex, where the brain actually analyzes what it's looking at. The other is fast and sloppy, a shortcut straight from the senses to the amygdala, skipping conscious thought entirely. That shortcut exists for a reason. When a branch is falling toward your head, you don't want your brain carefully considering whether it's really a branch. You want your body moving first and asking questions later. But that same shortcut fires for things that were never actually dangerous. A tense conversation, a crowded room, a phone buzzing at 11 at night. Your amygdala doesn't know the difference between a predator and a Slack notification. It just knows something changed, and change to an ancient survival system has always meant danger until proven otherwise. Here's where it gets stranger, though. In the wild, threats end. A leopard either catches you or it doesn't. Either way, within minutes, it's over. The stress response spikes, and then it releases. Modern threats rarely end like that. Biologist Robert Sapolsky spent years studying this exact gap, comparing the physiology of stress in wild animals to the physiology of stress in modern humans. In his research, he pointed out something unsettling. A zebra's stress response turns on when a lion is chasing it, and turns off the moment the chase ends. But a human's stress response can stay switched on for hours, even days, triggered not by an actual predator, but by the memory of an argument, or the anticipation of one that hasn't happened yet. Your body cannot tell the difference between a real threat happening right now and an imagined threat happening in your head, which means you can trigger the exact same flood of adrenaline and cortisol just by replaying an awkward conversation in the shower. Think about that for a second. Somewhere in your skull, ancient machinery built to keep you alive on a savanna is treating your inbox like it might eat you. And this isn't a flaw exactly. It's a mismatch. The system is working precisely the way it evolved to work. It just evolved for a world that mostly stopped existing. The problem is what happens when the alarm never fully shuts off. Neuroendocrinologist Bruce McEwen coined a term for this: allostatic load. It's the cumulative wear on the body from a stress response that gets activated over and over, rarely resolving, rarely finishing its cycle. Elevated cortisol, chronically, doesn't just make you feel anxious. Over time, it can affect memory, immune function, even the structure of the brain itself. In other words, your body was built for short, intense bursts of danger followed by recovery. It was not built for a slow, constant hum of low-grade alarm that never quite ends. So why hasn't evolution caught up? Why hasn't this system updated itself for modern life? Because evolution doesn't work on a deadline. It works across thousands of generations. And in evolutionary time, the last few centuries are nothing, a blink. The human brain you're using right now is, in almost every meaningful way, the same brain your ancestors used to survive lions, floods, famine, and each other. That brain kept your ancestors alive. It's the reason you exist at all. It just never got the memo that the leopards mostly left. There's something almost moving about that if you sit with it. Every time your heart pounds before a difficult conversation, every time your stomach tightens before opening an email you're dreading, you're not broken. You're not overreacting in some unique personal failure. You're running software written for a world of rustling grass and unseen predators, applied to a world of deadlines and notifications. Your ancestors survived because their bodies took every unexplained rustle seriously. You inherited that same seriousness. It just doesn't have anywhere to put it anymore. So the next time your pulse spikes over something that logically shouldn't matter this much, you might remember where that feeling actually comes from. It's not weakness. It's not overthinking. It's 50,000 years of survival instinct, misfiring in a world it was never designed for. Your heart is racing, your palms are sweating, you're staring at an email, and somewhere behind your eyes, a very old part of you is still checking the grass for lions.